Angles theorem, converse. Why is this the converse?
Because it doesn't say that it's already a parallelogram. It's asking you to prove that it is.
Excellent. We're asking to show that it's a parallelogram, so therefore it has to be the converse. This is opposite angles, converse theorem. Okay? Now, if we're being technical, right, there should be a parallelogram word up here, but I was not that picky on your quiz, okay? If you put opposite angles, converse theorem, you're Gucci, okay? Number 2, Christina? Excellent. This is diagonals, converse theorem. Charlie, we're going to say the same thing?
Of course.
Why?
Because, like, you see, like, for the other one the other theorem thing, like, with diagonals, but, like, from 7.2.
Okay.
It, like, didn't have, like, 1 and 1 and 2 and 2. Like, the lines will have 2 congruent marks.
Correct.
It's opposite.
Very good. So we have 2 sets of congruent marks, right? What's the main thing? There's a word that's very important in this theorem.
They bisect each other.
They bisect each other. Love it, Emma, okay? So remember, if your diagonals bisect each other, you're automatically dealing with the parallelogram, okay? And you can use the converse of the diagonals theorem to prove that. Cool beans? All right, any questions on the warm-up? So again, this is Chapter 7, Section 4, Special Properties of Parallelograms, or Properties of Special Parallelograms. And the first 3 are rhombus, square, and rectangle. So go ahead and get these definitions copied down. Does it say anything about sides? No, okay? So that's why a rectangle, right, just needs 4 right angles. That's why, you know when you normally think about a rectangle, you think about like where one side is a little bit longer, one set of sides is a little bit longer than the other one, okay? That's because all it needs are 4 right angles, okay? A rhombus, though, is a parallelogram with 4 congruent sides. But what doesn't the rhombus talk about in its definition? Christian? The angles, okay? So in a rhombus, you're going to see it look a little bit like this, where every single side, I know that's a bad drawing, it should be the same length, okay? So every single side in a rhombus is going to be the same length. And then a square is just a hybrid of both. So it needs to have 4 right angles and 4 congruent sides. So in its diagram with its pieces all there, all of the sides are the same length and all of the angles are 90 degrees. Christian, what's up?
So technically, a square is a rectangle, a rhombus, and a parallelogram?
Very good. A square is a rectangle, a rhombus, and a parallelogram. Okay? So squares are the most specific in terms of all 3. Okay? Because it needs both the properties of a rectangle and it needs the properties of a rhombus. Now, notice not all parallelograms are rectangles and not all parallelograms are rhombuses, okay? So we talked about parallelograms before. Not all of those fall into these categories, okay? These are more specific, special cases, all right? Now, a diagram that kind of explains that is on... All right, let's jump back to our corollaries, okay? So the rhombus corollary is very similar to the definition. It says a quadrilateral is a rhombus if and only if it has 4 congruent sides. So ABCD is a rhombus if and only if AB is congruent to BC, CD is congruent to AD, and all of them are congruent, okay? So the measure of each of these, for example, let's just fill it in there, could be 4 units, 4 units, 4 units, and 4 units, okay? So it works both ways. If all 4 sides are congruent, then it's a rhombus. And if it's a rhombus, then all 4 sides are congruent. That's why we write it as if and only if, okay? Remember, if the conditional works in both ways, it's if and only if. Same thing for a rectangle. So quadrilateral is a rectangle if and only if it has 4 right angles. So if all of the angles in a rectangle are 90 degrees, then we've got a rectangle, okay? So it's ABCD is a rectangle if and only if A, B, C, and D are right angles, okay? That means they're all congruent, they're all equal to 90 degrees. And the last one, the square corollary. So the square corollary is a quadrilateral is a square if and only if it is a rhombus and a rectangle. So it has to fall under both categories. All congruent sides, all congruent angles. Okay? All right, that's where I want to slide. This slide, what slide is this? 5? or 6, okay? Where it says all parallelograms fall into this box, right? Where the opposite sides are parallel. Now, a rhombus has 4 congruent sides, and rectangles have 4 congruent angles. Based on this Venn diagram, where they meet in the middle, that's where squares are, okay? They have both the properties of rhombuses and of rectangles, okay? So they need to have 4 congruent angles of 90 degrees and 4 congruent sides. So, a rhombus diagonals theorem. So you guys remember, all 3 of these shapes, a rhombus, a rectangle, and a square, they're all parallelograms, right? Because their opposite sides are parallel to each other, okay? Now, the diagonals of a parallelogram do what? We just talked about in the warm-up. They bisect each other, okay? So they're the same distance. If you are a rhombus, your diagonals not only bisect each other, but also form a 90-degree angle. So what I need you guys to do is in that figure, the main topic here is you need to highlight that 90-degree mark at the diagonals, okay? Now, if this angle is 90, what would be this angle? 90. What would be this angle? 90 and 90. Okay, so all 4 angles that are created from that intersection of the diagonals are all going to be 90 degrees, okay? They're all perpendicular. Got it? This is only for what kind of shape? A rhombus, okay? Now, opposite angles theorem, okay? So, the rhombus also says that if you have 2 diagonals, okay, their diagonals will bisect the original angle, okay? So look at angle A. What's happened to angle A when you drew the diagonal? It's bisected. It's cut into 2 equal parts, okay? So those 2 angles for angle A are also going to be congruent to the 2 angles for angle C. Why are these 4 congruent angles? Why are those 4 angles at A and at C congruent? Yes, alternate interior. Very good. They are 2 parallel lines cut by a transversal, so alternate interior. You can also think about it, it's a parallelogram, right? Because it's a rhombus. So don't opposite angles have to be congruent? And if they're bisected, it's just half of the original angle. Half of the original angle. Same thing happens for D and for B, okay? Okay. All right. And then the last one is a rectangle diagonals theorem, okay? So for a rectangle, your diagonals, not only do they bisect each other, but every single part is the same length, okay? So you remember for parallelograms, we knew that they cut each other in half, but were the diagonals the same length? No. For a rectangle, your diagonals are the exact same length. They become 4 congruent parts. Do you see how all 4 of these are congruent? Okay? That's a huge thing for a rectangle. Now, what do you think, which of these 3 theorems apply to a square?
Yes.
All of them, okay? So a square is also a rhombus, so it has diagonals that are perpendicular. It's a rhombus as well, so its angles are bisected, okay? And it's also a rectangle, so it also has 4 congruent parts when the diagonals intersect. What's up, Christian? Yes, but be careful here. So yes, you can say that these 2 are congruent and these 2 are congruent, okay? But it's not a rectangle, right? So they're not all the same length, but they do bisect each other, okay? And they also technically form a 90-degree angle. That has to do with parallelograms. So you remember when we said parallelogram diagonals theorem? That said that they bisect each other? You have to remember all 3 of these shapes are special types of parallelograms. So all the theorems that applied for parallelograms also apply to these. Great question, Christian. Is there a converse for these? Wow, that's 7.5. Very good. Okay. Anything else?
Why'd you say
You're
that?
gonna come. It's gonna get them out there.
All right.
You're gonna make me stressed out by
This, what was it called? Rhombus opposite angle.
thinking ahead.
Let's do some examples, okay? We've got a ton of examples just to reinforce what we're learning, okay? Quadrilateral ABCD is a rhombus. Find the measure of each angle. All right, it's a rhombus. So, what would be the measure of ACD? Zoe?
62.
Why is it 62?
Because one AC bisects the angle.
Excellent. That's perfect. AC cuts this angle in half, right? So the other side must also be 62 degrees. Okay? And it was asking us for ACD, which if we take a highlighter, go from A to C to D. Do you see how that's that angle? Okay? Now, what theorem do we apply to get here? It is the opposite angles rhombus theorem. They're hard to remember. Rhombus opposite angles theorem. Now, while we're working on this, what other two angles are also 62 degrees? Gabby, give me one of them. DAC, very good. Anyone know the last one? Mariana?
CAD. No.
CAD would be that same angle. One more. Emma? BAC, very good. Okay, so we know all four of those angles are 62 degrees. All right, now it says find the measure of DEC. DEC. Remember, what kind of shape is this? It's a rhombus. Emma, what do you think?
90.
Ayo, why is it 90?
Because of the rhombus diagonal theorem.
Excellent. Rhombus diagonals. Oops.
Who came up
There.
with the word rhombus?
Someone who wanted to make our lives super difficult. But that's a great question. All right. Next, it says, what is the measure of EDC? There's two ways you can figure it out. Xavier?
28.
Why?
Because the measure of the whole angle, ADC, has to be equal to 56.
Why?
Because it has to be supplementary to the other angle.
Very good. So you're saying that the measure of this angle BCD is what?
124.
124, because you just took 62 and added them together, right? And then you said this one has to be supplementary with that one, so this one has to be 56. And then how'd you get 28?
Because BD bisects.
Exactly. Very good. So this one must be 28 degrees, and this one must be 28 degrees.
Wait, it's 56, and that whole angle is 56?
Yeah, the whole angle. Very good, okay? And then we just divide 56 by 2 to get 28 degrees for each of them. Excellent, Xavier. Okay, and number 4, ABC. Emma? 56, baby, okay? Because remember, it's opposite ADC, so this will also be 56 degrees.
Angles.
Remember, is a rhombus a parallelogram?
Yes.
Yes. Correct. But remember, we're talking about ABC. So that's the whole angle. Do you see the difference there? Good. Good questions. Okay, what else? Any other questions on this? Okay, I won't. One is a rectangle. Okay, so guys, you're gonna have to move the letters. So N, cross out N, it should be over here, and cross out O, it should be over here. Okay, everything else is in the right spot. So what's the measure of angle PON? PON. Zoe? 58.
No, it is.
Well, what kind of shape is this? Rectangle, right? Is it a rhombus?
No, it's a
No. Okay, so all the rules that apply to a rhombus, right, do not apply to all rectangles, okay? So the rules that apply to a rectangle is formed by 4 90-degree angles. So any angle inside this figure must be 90 degrees. So this must be 90 degrees. Okay? Now, that's a very common mistake, so I'm glad that Zoe said that, okay? Don't get confused. Make sure you use what it's telling you the shape is. It says it's a rectangle. So this angle must be 90. What would be the measure of PMO? Xavier?
51.
51. How'd you get that?
Because it has to be 90
Correct. This entire angle of PMN must be 90 degrees. Do you guys agree? Because that's the definition of a rectangle. But now, do you see how these angles are not bisected anymore? Because it's a rectangle, not a rhombus. Do you guys see the difference here? Okay. So we're going to say that this is 51 degrees. What's PL? Gabby? 12. Why? No, those are called diagonals. Very good. Okay. What do we know about diagonals in a rectangle? What do we know about diagonals in a rectangle? Emma? They're all congruent. So LO we can also put as 12. PL is 12. And ML will also be 12. Okay. That's the big thing for rectangles, is that every single piece of the diagonal, once they intersect each other, is going to be congruent. All right. MO. What would be the length of MO? Christian. 24, baby.
How?
24 times 2.
12 plus 12?
You add them together. 12 plus 12.
Yeah, you can just do 12 times 2.
So this would be ML. ML plus LO will give you MO. All right, questions? Yeah, Christina.
Number 2, 90 minus 29, that's 61.
Yeah.
You might be right. 90 minus 29.
I'm so confused. Why?
You cancel these out. You bring over. This becomes an 8. This becomes a 10 minus
Xavier.
9. Xavier, you tricked us. Thank you, Christina. That should have been 61, guys. Good catch.
Well, and me partial credit because I was just about to say that. I was doing a calculator.
You did it though.
Yeah, but you're using a calculator. Stop using a calculator, Talia. So yes, thank you very much, Christina. That should have been 61 degrees. You fixed my video too. Okay. Okay, quadrilateral. MORE is a square. MORE is a square, okay? So all the properties of rhombuses and of rectangles apply here, okay? If ME is 7x minus 3 and MO equals 6x, how can we find x? No.
Equal them to each other.
Why, Janellis? This is 7x minus 3. You're absolutely right. And this is 6x. Why do these two need to be congruent? Zoe? Excellent. All the sides and all the angles are congruent. So MO must be equal to ME. Therefore, we can set them equal to each other. So 6x must be equal to 7x minus 3. And someone walk me through solving this.
You subtract 7x from both sides.
Yup. Subtract 7x, subtract 7x. We're going to get negative x equals negative 3.
And
Divide by
1. Negative 1.
negative 1. And you get x equals positive 3. So key here, guys, is a square is both a rhombus and a rectangle. So every single property that applied to either of them applies to squares. Got it? Okay. So if MT is 4x and TE is 3x plus 2, find OE. Well, let's change our colors and let's fill that in. MT is 4x, so put a 4x here. TE is 3x plus 2. How could we find OE? Gabby? Why?
Yeah,
Why?
because they're congruent.
Why are they congruent? Why is MT, I agree with you, MT should be equal to TE. Janellis?
Is it because it bisects?
Very good. Not only does it bisect it, but a square is also what shape? A rectangle. And rectangles have 4 congruent parts when their diagonals intersect, okay? So this is congruent to this, which is congruent to this, which is congruent to this, okay? All right, so once we know that, we set these equal to each other. We've got 4x equals 3x plus 2. Agreed?
Yeah.
How do we solve? Subtract 3x from both sides. You're going to get x equals 2. But that's not what it's asking us for.
Plug
Yeah,
it in.
that was one. What?
You plug it into both to see what the whole angle is.
For one.
Like
Kind of. You definitely plug it in. Wait, what?
No, it's right. It's what?
Like you'll plug it back in, and then once you get that angle, you know all the other, or not angle. Once you get that line segment, you know all of them are the same.
Very good. So you just multiply it by 2. Okay? So do you see how OE is 2 lengths long, right? Let's plug it into 3x plus 2, get an answer, and then multiply it by 2, because it's going to be double that length, okay? So we have 3x plus 2, that's what was that, MT? No, TE. And then we plug in x equals 2. We're going to get TE is now 3 times 2 plus 2. So TE equals 6 plus 2. So TE equals 8. You guys with me? So if we know that this little piece is 3x plus 2 is also 8, do you agree that OT would need to be the exact same length? Yeah. So if this is also 8, what's the length of the whole thing? 16. So OE equals 16. Okay? You can think about it as taking TE, adding it to itself, adding another piece that's the exact same length, or just multiplying it by 2. Okay? Now, the reason we can do this is because what shape were we dealing with? A square, okay? If this was a rhombus, okay, we could not set MT and TE equal to each other, okay? If this was a rhombus, we can't do that. It had to be a rectangle. And we know a square is both a rectangle and a rhombus. Wow, that was weird. Oh, go back. Parallelogram with one right angle becomes what shape? A rectangle or a square, okay? So we're going to leave it that it has to be a rectangle. Now, let's see why this works, okay? Let's see why this works. Draw a parallelogram. Any parallelogram. And make one angle 90 degrees. I'm going to make the bottom left angle a 90-degree angle. Okay? What do we know, since this has to be a parallelogram, what else can we fill in for our diagram? Christian?
I'm not the answer, but I understand the question, but technically, because it says a parallelogram with one right angle, it wouldn't be anything because a rectangle and square have 4 right angles.
Oh, are you saying, okay, so, I see what you're saying now. So what Emma and Christian are saying is that since it's it's a parallelogram, right? And it says it can only have, does it say it can only have one right angle? So if it has one right angle, okay, the key here I want you guys to get is if you have a parallelogram with one right angle, all the angles need to be 90, okay? Now, let's see why that happens. What do we know? What can we fill in based on this diagram? We have the bottom left angle is 90. What else can we fill in? Emma?
This one.
Top right?
Yeah.
Why does this also have to be 90?
Opposite angles theorem.
Excellent. The opposite angles theorem, okay? What else needs to be 90? Xavier?
The other 2 angles,
Why do these two also need to be 90?
because they have to be supplementary to the
Correct. Because remember, 2 angles that are next to each other in a parallelogram add up to 180. So if we did 180 minus 90, what are we going to get? 90. So all of the angles must be 90
Wouldn't it
degrees.
also just be the theorem that a rectangle has all like equal 90?
Yes, but remember, it didn't tell us it was a rectangle, right? It said what kind of shape is a parallelogram with one right angle. Now, if you're going to take that literally, like Emma and Christian did, okay? If it has one right angle, then it can't be a parallelogram, right? Because if not all the angles are 90, then we wouldn't have a parallelogram. So good catch, guys, okay? But if it has one right angle, all the angles must be right, okay? Questions? All right. Now, I want you to classify this special quadrilateral and explain your reasoning. Be as specific as possible. What shape are we dealing with here?
That's a diamond.
What kind of shape is this, and can you explain? Zoe? You think it's a rhombus.
Be certain in your answer.
Zoe, why do you think it's a rhombus? Very good. All the sides are congruent. Okay? Is this a rectangle?
No.
Why not?
Because not all sides are congruent. Two sides of them are.
So a rectangle says nothing about the sides. What does the rectangle say?
It has to be all 90 degrees.
All 90 degrees. So this 170-degree mark means it cannot be a rectangle. Can it be a square? No, because it can't even be a rectangle, okay? Yeah. So it is only a rhombus. Zoe is spot on, okay? As long as all the angles are not, or sides are the same length, it is a rhombus, okay? Not a rectangle or a square because that one angle is 70 degrees. Gucci? Yeah. All right. Always, sometimes, or never. Please cross out the very last one. We haven't learned about a trapezoid yet, okay? A rectangle is a rhombus. Always, sometimes, or never. A rectangle is a rhombus. Xavier? Never. Who agrees? Who disagrees? Why?
Because a square is a rectangle and a square is also a rhombus.
Excellent. So this answer is sometimes.
Syllogism.
Why is it sometimes? And it's because what's a square?
A rectangle.
Both a rectangle and a rhombus, okay? So sometimes if you have a square, it is both a rectangle and a rhombus, okay? But most of the time I would agree it's not, okay? But Xavier, be careful with that, okay? Know that squares can be both. A square is a rectangle.
Always.
Always, okay?
True. Oops.
Always, okay? We have one more slide. And it's the coordinate plane, okay? All right, this one, not gonna lie, is gonna be fun, okay? All right, so example 7, decide whether the quadrilateral parallelogram with vertices A, B, C, and D is a rectangle, a rhombus, or a square, and give all the names that apply, okay? Now, what I want you guys to do, we are gonna get a little detailed in here. We're gonna use the distance formula, we're gonna use the slope formula. Okay, but we need to change our mindsets a little bit, okay? I need you guys to work with me on this problem, okay? This is our last question, all right? Best for last. All right, so let's put A, which is at -2, 6. That's A. B is going to be at 6, 8. C is going to be at 4, 0. That's C. And D is going to be at -4, -2. So I'll give you guys a second. Put all those dots on and then go ahead and connect them. You guys are too much. What? What do I like teaching more? So there are two things we need to check, whether it's a rhombus or a rectangle, okay? Now, if it's both a rhombus and a rectangle, what shape is it? Square, okay? So we're looking to see which conditions are met, okay? The first, let's check if it's a rectangle, okay? So write down rectangle. This is the check to see whether it's a rectangle. Now, if it's a rectangle, that means every single angle must be 90 degrees, okay? What do we know about two lines that intersect if their angle is 90 degrees? We have a word for it. Perpendicular, okay? So we're going to look at the slopes and see if those slopes are perpendicular to each other, okay? So let's look at the slope of AB. Okay? And I just picked AB out of a hat. You could have picked any side, okay? All right, so what is the slope of AB? Jaden?
2 and 9.
Almost.
8.
Very good. So what's the actual slope?
4.
You don't simplify it, do you? Or no?
You do simplify it.
I thought you said you don't.
Yeah.
Because you want to make sure the slopes are the same when he said that.
Point of interruption, could you please send Xavier Dominic to guidance whenever it is convenient for you?
Yes.
Thank you.
Do you want to wait till the end of this problem? Okay. All right. So the slope of AB, yes, it's going to be 2/8, okay? But I do want you to simplify it. When did I say that I did?
Yes. The day before the quiz. The day before the quiz. said not to simplify because he said the simplified answer. And you said
3/6, and I said, oh, 1/2.
Oh,
you
okay.
said not to because you want to get the same slope.
I think I meant don't just write it as 1/4, okay? Write it as 2/8 and then simplify, okay? Because I want you to see the original slope and then how it simplifies, okay? All right, so 1/4 is your slope of AB. What would be the slope, okay, of either side that intersects AB? So let's do DA, okay? So do you see how DA intersects AB? These slopes should be perpendicular in order for us to have a 90-degree angle, okay? Now let's see. What's the slope of DA? Zoe? It's close. It's going to be +8 over +2, okay? So this is 8/2, which simplifies to? 4. Ah, so if it's perpendicular, they need to be opposite reciprocals. Are they reciprocals?
Yes.
Are they opposites?
No.
No. So are these two perpendicular?
No.
Not perpendicular. Therefore, it's not a rectangle. So if it's not a rectangle, what else is it not?
Square.
It's not a square.
So just by that, we just figure out.
It's just nothing.
Okay? Now, you also cannot just say because it's not a rectangle, because it's not a square, that it has to be a rhombus. You have to prove it, okay? What do we know about rhombuses?
At least one
What's
side
that?
is 90.
What?
At least one angle is 90.
No, that's a rectangle. What do we know about rhombuses? The sides are congruent, okay? So, we have to figure out the distance of AB and compare it with the distance of AD. Now, the reason that we're picking two sides that are next to each other is because this is already a parallelogram, and it says so in the instructions. Do you see how it says determine whether the parallelogram ABCD with vertices this? Okay? So, AB, if it's a parallelogram, has to be congruent with which other side? DC. So we already know that. What we need to prove is that two sides that are next to each other in the figure are congruent. Once we prove that, we know it's a rhombus, okay? Because doesn't AD have to be congruent to BC? So we know that all of them are congruent if we can prove that two that are next to each other are congruent, the same length, okay? So yes, let's use the distance formula, our favorite, and label this portion rhombus check, okay? So we're checking for the rhombus.
Mr. Yurko.
Yes.
Each time you make us use the distance formula, you're ranking in my favorite teacher list.
Well, that's awesome, okay? Because I do not want to be the best. All right, so our rhombus, okay?
Oh, we know that's not true.
We're going to do AB, right? And it's much easier if we can see the points. So put the points for AB. We're going to put A was -2, 6, and then B was 6, 8, okay? Now, there is a trick here, okay? There is a trick, okay? So what we're going to do is we're going to say, okay, this distance formula is the square root of x1 minus x2 squared. Or wait, did I mix that up?
Yeah, it's x2 minus x1.
Thank you. x2 minus x1. x2 minus x1 plus y2 minus y1 squared, okay? Now, make one of your points x1, y1, make the other one x2, y2. I'm just going to make A, x1, y1, and I'm going to make B, x2, and y2, okay? And then you just plug it in. So we're going to get, okay, the distance of AB is equal to the square root of x2, which is 6, minus x1, which is -2, squared. You guys with me? Okay. Plus y2, which is 8 minus y1, which is 6. Excellent. Okay? Squared. Now, AB equals, sorry, I clicked on something. Okay. The square root, what's 6 minus -2? 8.
What?
It's 8 squared. And then 8 minus 6? 2 squared. Okay? Now, before we move on, what was our slope, Jaden, what was our slope before we simplified of AB?
2/8.
2/8. Do you see how the 2 is the change in the y and the 8 is the change in the x? You don't see that? Okay. So remember how slope is rise over run, right? Rise is y, right? Change in y. So our rise, our 2 should be the y value subtracted, which is 2. And our run, which is 8, should be our x value subtracted, which is 8 down here. Okay? Do you guys see that? Or no?
Oh, so that's how you could check.
Very good. Okay? This is a great way to check yourself. Okay? Now, watch. Isa, stop. All right. What is 8 squared, peeps?
4.
Okay, so AB equals the square root of 64 plus, what's 2 squared? 4. What's 64 plus 4?
68.
So the square root of 68. Now, leave it like this for now, okay? All we're checking is that when we do the other one, we should get the square root of 68 as well, okay? Now, we have to use the distance formula for what other side?
BC. CD.
No. AD, okay? So we're going to find AD.
Why is it 80?
It's going to be the square root, because remember, we have to pick two sides that are next to each other. Because it's already a parallelogram. We know that if this is square root of 68, this has to be the square root of 68. But we need to prove that the two that are next to each other are the same length as well, okay? All right, so A was -2, -6. D was what, -4, -2? So we'll make this now x2 and y2, okay? All right, so set up our formula. We're going to do x2 minus x1. So it's going to be -4 minus -2 squared plus, and then -2 minus 6 squared. So we've got AD equals the square root of, what's -4 minus -2? -2 squared plus, what's -2 minus 6? -8 squared, okay? Now, before we move on, go back to your slope of dA. Do you see how the change in the y was 8? The change in the y is -8 here. The change in the x was 2. The change in the x is 2.
So now it's negative.
Isn't that crazy? Okay.
Now it's negative.
But now it's negative. But do you see how they're both negative?
So
Okay.
that's how we would know that it's perpendicular.
Yeah, but then
It's
it
the
turns into a
opposite.
positive.
No, it's not perpendicular though. Okay? Okay? Now, since we square these, right? Since we square them, they're going to be positive anyway. So the sign doesn't matter. The value does. Stephanie? Yes. Christian?
Isn't it kind of like, don't you not have to do like the second distance formula because you already know that the BC and AD are perpendicular.
It's, yeah.
Can we just
No,
skip
they're
to
not
this?
perpendicular.
They're parallel and they're the same distance.
They're not parallel.
Yeah, don't they have the same slope?
No. One slope was 1/4 and the other slope was 4.
I'm talking about, or I mean, the top, like the line that, like.
All right. So we're going to apply the distance formula. And we've got, what's -2 squared?
4.
So AD equals the square root of 4 plus
64.
64. And that's equal to the square root of
68.
68. So what do we know about the two distances? They're the same. So if they're both the square root of 68, then what kind of figure do we have? It's a rhombus. Okay?